Okay, in Core 1 today, we took a look at some more geometry that you should have learned before, but that we're reviewing just in case, which is going to involve prisms. Now, we looked at a simple definition of prisms as being any 2D shape stretched into 3D. So we can take this and look at some examples. If I have a rectangle, I can turn it into a 3D rectangle by basically stretching it into a third dimension. I can do the same thing with the triangle.
FAQ, please come to the main office to meet your mother. FAQ, please come to the main office.
And stretch the triangle into 3 dimensions. Now the important part is that the front and the back, or the top and the bottom, or wherever it is, the main shape is the same exact on both ends. Exact same shape. Now we can do this with many shapes, okay? We can have a circle that is stretched into 3D. Technically this is called a cylinder, but it meets the requirements of a prism. And we can have other non-conventional shapes, as long as it's the same exact shape on the front and the back. Good enough way to draw that. Okay, same exact shape, front and the back. Now, with the prisms, what we're going to eventually look at is how to calculate surface area and volume. Now, this is in contrast to 2D shapes, which have area and perimeter. So this is our 3D. Now, let's look at some of the examples we looked at in class as far as calculate the volume of a 3D prism. So, simple example to start with. A rectangular prism, it's called that because it has a rectangle on the front and the back. Let's say it is 5 inches, 3 inches, 2 inches. Now, what you need to do first, no matter what the shape is, find the area of the primary shape. The area is 5 times 3, so it's 15. So area 5 times 3 for this shape. Now, volume is area times depth. So in this case, it is going to be that 15 times the 2. So our volume is 30, and our units are inches cubed. Now, let's take that and apply it to some other prisms that might look slightly more difficult, but aren't actually. Let's say I have a triangle stretched into 3D. And let's say on that triangle I have certain measurements. 20 centimeters, 8 centimeters, a height of 5 centimeters, and let's say I have a measurement over here, 10 centimeters. Now, you'll often see, especially in problems like this, numbers that you don't actually need, because the area of a triangle is base times height divided by 2. 8 times 5 divided by 2, we get 20. It is not needed to use the 10. Now, same thing up here, volume, area times depth. So this 20 times that 20. So 400 centimeters cubed. I'm going to make a note here where these final numbers are coming from. Okay? Always times the depth in the end. Now, let's look at one more example, a slightly more complicated one. Is the example of a circular prism, or just called a cylinder. Now, a cylinder has only two measurements that are needed. We'll say that is 5 inches radius and 40 inches deep. Now, area of a circle is pi r squared. So in this case, it's pi times 5 squared, which is pi times 25. Multiply by 3.14, so 25 times 3.14. I get 78.5 as the area of my circles. Take that 78.5, multiply it by the depth of the shape times 40, and I get 3140 inches cubed. Once again, that 40 comes from the depth. Now, since that's as far as we got, we will only have volume on tomorrow's quiz, not surface area as well. We will get to surface area next week. Thank you for watching.